The belts or ropes are used to transmit power from one shaft to the other by means of pulleys which rotate at the same speed or at different speeds, right? The amount of power transmitted depends upon the following factors. So we know these are used to transmit the power from one shaft to the other, right? So it can be like this, right? So these are called as belt drives, which are driven by the pulleys. All right. So here we have a driver pulley, and then we will have a follower pulley, right? So there are different types. Open belt drives are there, closed belt drives are there, V belt drives are there. We'll see one by one. So they may rotate in a particular direction to transmit power from one shaft to the other. So if you see, this is the shaft which is generating the power, right? This is the shaft which is generating the power, but this power needed to be transmitted to this location, right? So maybe some work need to be done in this location. So in that case, we need to transmit the power from this point to this point, right? So based on the distance between these two points, we'll go for which method to use, right? Either we can go for belt drive, sometimes it's called as rope drive also, right? Or else we can go for chain drives, right? Or else we can go for gears, right? Depend on the distance between these 2 points from where the power is generated and where the power need to be transmitted, we'll go for the type of drive, right? The amount of power transmitted depends upon the following factors. Velocity of the belt, right? So if it is power, then you know we have certain equations for power, right? Usually in day-to-day life, we have an equation that is work upon time, right? Similarly, here also we have some equations for power. So based on them, the factors which decide the transmitted power are, some of them are velocity of the belt. So what is the velocity? The belt was rotating. Tension under which the belt is placed on the pulleys. So you know, if it is a belt drive, there must be some tension, right? There must be some tension. So this tension also has an impact on the amount of power transmitted. The arc of contact between the belt and the smaller pulley. So arc of contact means the arc where the belt and the pulley is in contact with, right? Belt and the pulley is in contact with, right? So particularly it's for smaller pulley, right? So arc of contact between the belt and the smaller pulley, right? So this is another factor which describes the power transmitted. So I told you, like, we can use any one of the methods. Either it can be belt drive, or it can be chain drive, or it can be rope drive, or it can be gear, to transmit power from one point to another point, right? So the conditions under which the belt is used, particularly when we use this belt, now we are going to see that the shaft should be properly in line to ensure uniform tension across the belt section, right? So inline mean the driving shaft, okay, and the follower shaft need to be in line with each other, right? So they must be in line. They should be aligned, right? They should be aligned to ensure the uniform tension across the belt section, right? So you know, if this belt, then it must have tension on the belt, right? Here also it may have some tension, but the top upper part tension and lower part tension would be different. That's different story. We'll go for that later, right? But it is having some tension, right? To ensure the uniform tension across the belt section, right, it should be in line, right? So we know this is a kind of front view. If we go for top view, how will it look like? This is going to look like this, right? So there'll be a belt, right, and there'll be a pulley. This side also there'll be a pulley, right? So this is the cross section of the belt, right? So this one need to be in line, right? So aligned properly. So between this pulley, and the belt, they need to be aligned properly, right? Or in other words, they should be in line. The pulley should not be too close together in order that the arc of contact of the smaller pulley may be as large as possible. Right? Pulley should not be too close, right? So say for example, you have two pulleys, right? One is a bigger pulley and the other one is a smaller pulley, right? So if they two placed like very near, right? Very near, we'll consider like two situations, right? So this is situation number one, and we'll consider another situation like this, right? So the first diagram you can see they are too close, right? They are too close. Second diagram, if you see, they are not that close, right? They are in a capable distance enough, right? Okay. So in order that the arc of contact of the smaller pulley may be as large as possible, right? The previous slide I told you the arc of contact has some effect on the power distribution, right? Or transmission of power. So this is the smaller pulley, right? This is larger pulley and this is smaller pulley. Similar way, this is larger pulley and this is smaller pulley, right? So arc of contact, I told you the contact between the pulley and the belt, right? I can draw it by some other color, right? So this is going to be the arc of contact, right? Contact between the belt and the pulley. So here in this diagram, this is going to be the arc of contact, right? Contact between the arc of a belt and the pulley, right? So in this diagram, first diagram, if you see the arc of contact on the smaller pulley and arc of contact of the larger pulley in these two diagrams, if you compare, right? So this is small, right? This arc of contact is small, but here that is large, right? This is large. So if you place this one too closer, right? If you bring it like even closer than this, the arc of contact would be rather low, right? So that's not that desirable property to transmit the power, right? So this will give you like better performance than this, right? So this is why the pulleys, I mean distance between the pulleys is also a reason need to be considered, right? On using a belt drive. Then the pulleys should not be so far apart. So this is another condition. So here they should not be too close. Here they should not be too fast as, I mean too far as well, to cause the belt to weigh heavily on the shaft, thus increasing the friction load on the bearings. So if they are too far apart, right? So we need a moderate distance. So if I consider this as a moderate distance, so this is like a low distance between pulleys. This is moderate distance between pulleys. And I'll draw something here. This is far apart, like far from one another, right? So if you connect these two, right, driver pulley and driven pulley, they are far apart. One is here and the other one is there, right? So I'll consider this as driver. Driver is the pulley which is generating the power, and this one is the follower, right? Follower is the pulley which is driven according to the driver, right? So if the driver is moving this way, the follower will automatically move that way, right? So if they are too far apart, what will happen? We know this belt is also having some weight, right? So already there is a tension in the belt, right? Tension in the belt. Also, this has some weight. So what will happen? The weight of this portion, right? Weight of this portion will act somewhere here, right? Will act somewhere here. Similar way, the weight of this portion, this will also act somewhere here, right? So at last, what will happen? This belt may go like this, right? Similar way, this belt may also go like this, right? Because weight is acting on this, right? So this is not that desirable property. This may lead to, you know, a kind of shock. So if it is like this way, when it is passing by this point and passing by this point, right? This may generate a kind of shock, right? Again, that may bring a kind of amplitude over here, right? Like this. That may start to behave, right? So this may start to oscillate like this, right? If there is some weight over here, this may start to oscillate, depend on this tension and the velocity of the pulley which is rotating and the distance, right? So this is not that desirable property, right? This may in fact impact on the power transmission, right? That may not transfer the exact power which is generated by the driver to the follower. There may be some loss in between, right? So that's why this is not desirable to have the pulleys so far apart. So having too close is also not desirable. Having so far is also not desirable. Having them in a moderate distance is desirable, right? So these are few conditions under which the belt is used, and there are still more conditions. We'll see. Right? A long belt tends to swing from side to side, right? Causing the belt to run out of the pulleys, which in turn develops crooked spots on the belt, right? So maybe if I can draw a diagram, right? So if you see, this is a pulley and this is another pulley, right? This is driver and this one is follower, right? This is driver and this is follower. So in that case, a long belt tends to swing from side to side, you know, as like when we travel in a train, this may start to swing from side to side like this. Okay, so this is again not the desired property, causing the belt to run out of the pulley. So if you see, if I can draw a kind of a top view, right? So if this is your pulley and the belt would be slightly lower than the cross section of the pulley, right? This is a top view. You can just imagine. So this is driver and this is follower. This is our belt, right? So this belt is running over the pulleys. So if it is starting swimming this way and this way, right, sidewise, if it starts swinging, what will happen? Sometimes this may go out of the pulley, right? Sometimes this may go out of the pulley, and which may lead to the failure of that, right? Failure of the power transmission, right? So causing the belt to run out of the pulleys, right? Run out of the pulleys, which in turn develop crook spots on the belt, right? So there would be some spots where there would be tension. So if it is like moving this way, right? Say for example, after a certain time, say for example, this is how the belt is, right? So this has moved some part that side, right? So here, this part would be in tension, right? This green colored part, this would be in proper tension. While this part, right, the uncolored part, that is not in tension, but that's outside, right? So there's uneven distribution of tension would be developed on the belt, right? Uneven distribution of the tension, right? So this is not again a desirable property. Then the tight side of the belt should be at the bottom, so that whatever the sag is present on the loose side will increase the arc of contact of the pulleys, right? So if I can draw, I've already told you what does this arc of contact mean. Arc of contact is the contact between the pulley and the belt, right? So this is going to be the pulley and the belt, the tight side, right? So I told you there would be difference in tension, right? One side would be tight and the other side would be loose, and we'll see which side is that. So this side should be in tension, right? The tight side of the belt should be at the bottom, right? Bottom side should be tension, and this side would be loose side, right? So this may be loose compared to this. So if I can put it in the equation, the tension of L is lower than T, right? So this would be in high tension, and the top belt here, this one would be on low tension, right? So what will happen if the tension is low on the top belt? that may tend to bend like this, right? You know that. If there is low tension, right, that may tend to come like this, right? And if I can draw another diagram to compare, what will happen if the tension is on, I mean, loose tension is on bottom side, right? So here is your driver and the driven. This is tension, right? Now this side is in tension and this is loose side, okay? The bottom side is loose side. So I'm just taking this one as the comparison for the previous statement, right? So if this is loose side, how is it going to be? This is going to be like this, right? If this side is loose, then this is going to be like this. So we'll compare what will happen in these two cases, right? So here, right, the arc of contact, when there is looseness on the top belt, right, is from here to here, right? So this region is, right, this region is the arc of contact. You see, this region is the arc of contact. While in this case, right, on the other way, if the bottom pulley is loose and top pulley is tight, arc of contact is this much, right? So arc of contact is this much. Arc of contact means the contact between the pulley and the belt, right? So this side is going to be the arc of contact, right? So when you compare these two arc of contacts, you can see the arc of contact here is higher than the arc of contact here, right? And we already know the arc of contact has some impact on the transmission of power, right? So if the arc of contact increases, the power transmission increases. So if the bottom side is loose, right? If the bottom side is loose, what will happen? The arc of contact would be low, right? If the arc of contact is low, what will happen? The power transmission would be low, right? In this case, if the tight side is at the bottom and low side is at the top, what will happen? The arc of contact would be increasing, right? Arc of contact would be increasing. If the arc of contact is increasing, what will happen? The power transmission will also be increasing, right? Power transmission will also be increasing. So that is beneficial, right? So that's why the tight side of the belt should be at the bottom, right? Tight side should be at the bottom and the loose side should be on the top, right? It should not be like this, right? Tight side should be at the bottom and the loose side should be at the top. So what will happen? The whatever that sag in present the loose side will increase the arc of contact, right? Will increase the arc of contact. So in order to improve the power transmission, we need to increase the arc of contact, right? Then next point, in order to obtain good results with flat belts. So these are flat belts. There are different types of belts, right? Flat belt is there, V belt is there, round belt is there, right? We'll go for them. So in order to obtain the good results with flat belts, the maximum distance between the shafts should not exceed 10 meters and the minimum should not less than 3.5 times the diameter of the larger pulley, right? So I was discussing about the distance between the shafts, right? So here the maximum distance should not exceed 10 meters, right? So maximum distance is expected to be 10 meters in order to transfer the power efficiently, right? Good results, that is efficient. And the minimum should not be less than the 3.5 times the diameter of the larger pulley. So if I consider this as a larger pulley and this as smaller pulley, the distance between these two shafts, right? Distance between these two shafts. So this is the distance between these two shafts, right? If I can mention it as L, right? If I can mention it as L, this distance, that is L, should be greater than, right, 3.5 times of the diameter of the larger pulley, right? So if I can mention the diameter of this larger pulley as D and this smaller pulley as small d, right? Larger pulley capital D, small pulley small d, right? So this length between these two shafts, right? The length between these two shafts should be greater than 3.5D. In other words, should not be less than 3.5 times the diameter of the larger pulley, right? So this is a desired condition to generate and transmit the moderate power. And sorry, not moderate power, maximum power with moderate distance, right? Maximum power with moderate distance, right? So these are few conditions, right? These are few conditions to consider while we are using the belt drive. Then selection of a belt drive. So how and what are the parameters we will see while selecting a belt drive, right? One is speed of the driving and driven shafts, right? Speed of the driving and the driven shafts. So driving shaft is a shaft which is generating the power. Driven shaft is a shaft where the power need to be transmitted, right? And speed reduction ratio. So we know if the diameter is different, the speed would be different, right? The diameter is different, then the speed of those two shafts would be different. So those two pulleys would be different. So the reduction in the speed is called as the speed reduction ratio, right? Then power to be transmitted. So how much is the power to be transmitted? Is it like moderate amount or large amount, right? So this should be considered while selecting a belt drive. Center distance between the shafts, right? So if it is a factory or something, then the limited space is available, right? You need to use the space available very efficiently. So say for example, if this much is the only distance, I mean, or the space which is given to you to establish a belt drive, right? Then you need to think of how much is the power to be transmitted. So if this is a constrained distance, right? If this is all the management can give to establish a pulley, then you need to go for how much power need to be transmitted. So how fast this should rotate. So in order to transmit that much power, how much is the diameter, right? These all are like interconnected, right? So all these terms are interconnected with each other in order to fix a parameter, right? So this is the center distance between the shafts, right? So center distance between the shaft is also a parameter. Then positive drive requirements, right? So if there are any requirements, special requirements, then shaft layout, right? So shafts can be of like flat belt drive or V belt drive, okay, or quarter belt drive. There are different. Then space available. So this is almost similar to this center distance, right? Space available. So if there's a confined space, then we need to use that space effectively. And service conditions, right? So service conditions we know, right? So that is known for all the applications that we are using. So based on these factors, we may select a belt drive, right? We may select a belt drive. Then we'll see the types of belt drives, right? There are different types of belt drives. Depending on different classification or different purpose, we can characterize them, right? First one is the light drives, right? Light drives. These are used to transmit power, small powers, right? So based on the transmission of power, they are named as light drives, right? Small powers. So if they are transmitting small powers, then we call them as light drives at belt speed up to 10 meter per second, right? So here the belt speed is 10 meter per second. As in agricultural machines and small machine tools. So agricultural machines mean like this hand tractor, landmaster, right? Those kind of agricultural machines and small machine tools, right? So the velocity is up to 10 meter per second, right? So these all are called as light drives. Then we have medium drives, right? Medium drives mean these are used to transmit medium power at belt speed of 10 to 22 meter per second, right? So these are the specific areas you need to consider. So here medium drive means it is transmitting medium power, right? With a belt speed over 10 to 22, right? So light drive is less than 10, medium drive 10 to 12, right? Then we have heavy drives, right? Heavy drives. These are used to transmit large powers, right? Large powers with the speeds above 22 meter per second, right? As in compressors and generators, right? So these are called as heavy drives, right? So light drives to transmit light power with the velocity of less than 10 meter per second. Medium drive, medium power between 10 to 22 meter per second. and heavy drive, large power above 22 meter per second, right? So this is depend on the, this is categorized based on the use of the drives, right? Use of the drive. Then based on the types of belts, we can classify based on the types of belt, right? So flat belt, V belt, and circular belt. We can classify them in this way also, right? So here you see this is the pulley, right? This is a pulley, and here is the belt, right? Here is a belt. So as I told you, the pulley would be slightly larger than the belt to accompany any movement of the belt sidewise, right? But it would not be like that large, right? So this is that region, right? Flat belt, V belt also it does have that region, and circular belt also it does have another region, right? We'll see what does this flat belt mean. Flat belt is mostly used in the factories and workshops where a moderate amount of power is to be transmitted from one pulley to the another when the two pulleys are not more than 8 meters apart, right? So flat belt usually to transmit moderate amount of power, right? Moderate amount of power within the distance of 8 meters, right? Not more than 8 meters. So the distance between two pulleys or center of these two pulleys would be around 8 meters or less than 8 meters, right? And these are used to transmit moderate amount of power. Then I have V belt, right? V belt. So this is by the name V. You see the pulley is in the shape of a V. So this is why it is V belt. V belt is mostly used in the factories and workshops where a moderate amount of power is to be transmitted again from one pulley to another, where the two pulleys are very near to each other, right? So if the two pulleys are near to each other, right? If they are too near to each other, we will use this belt, right? Sorry, V belt, right? We'll use this V belt because if we use this flat belt, what will happen? The arc of contact would be low, right? As I told you, the arc of contact would be low. So there's more chance for slippage, right? There's more chance for slippage. So in this case, if we use this V belt, the slippage would be low. Slippage means the tendency to slip, right? You know what is a slip is. So slip means the driver moving without carrying the driven, right? So this would be rotating, but not carrying this one. So that is what called as a slip, right? So if we have a flat belt over here, there's a high chance of slip. So that is why if the distance between these pulleys are low, we need to increase the friction. For that purpose, we use V belt. So this, if they are very close, so if the distance is small, then we can go for V belt, right? So the V is carved on the pulley, and belt is also different, right? In order to accompany that shape, right? Then I have circular belt or rope, right? So this you see circular belt or rope, right? Circular belt or rope is mostly used in the factories and workshop where a great amount of power is to be transmitted, right? So power transmission, if it is great, then we'll go for this. From one pulley to another when the two pulleys are more than 8 meters apart, right? So if the two pulleys are more than 8 meters apart, and if it is necessary to transmit more power, huge power, then we will go for this circular belt. So there you see that is also in a V, like a kind of V cut, but it is still more surface contact is there, right? So if there is more surface contact, then there would be less slip, right? So that's why we go for this circular belt in like great power transmission as well as in large distance in the sense distance more than 8 meters between these two pulleys, right? Distance more than 8 meters when these pulleys are apart, right? So this flat belt, moderate power transmission, and distance is less than 8 meter. Circular belt, moderate power transmission, but the distance between the pulleys or shafts are more than 8 meters, right? So based on this also we can classify the types of belts, right? Okay, types of flat belts type. So now in flat belts we are classifying, right? So previous case, that is classification of belt drives. So that is flat belt is one, V belt is the other one, and the circular belt. Now within this one, we need to classify within this flat belts, right? First one is the open drive, right? Open drive. There's another one which is called as closed drive. We'll see that one in the next slide. So this is what called is open belt drive. Open belt drive. The open belt drive is used with shafts arranged parallel and rotating in the same direction, right? Shafts which is arranged parallel, right? So there you see, this is the axis and this is the axis, right? And rotating in the same direction, right? So there you see, this is rotating clockwise, driver pulley driven, that is also rotating clockwise, right? That is also rotating clockwise. In this case, the driver A pulls the belt from one side, right? So this driver pulls the belt from one side, that is RQ, right? This side. So from here it is pulling it and delivering it in the other side, that is upper side LM, right? So this pulls from here and deliver it to there, right? See, this is why this bottom side is in high tension, which is called as tight side, and top side is in low tension, which is called as slack side. So if you see the diagram, you see this is a kind of straight line, so which is tight, and this is, you see there's a kind of small bend, right? So this is slack side, right? And delivers it to the other side, that is upper side. Thus, the tension in the lower side belt, right? Tension in the lower side belt will be more than that in the upper side belt, right? So if I can put this tight side tension as A, no, A is already mentioned. So I'll put it as like E, right? I just naming it, right? And top side tension as F, right? So always E would be higher than F, right? E would be higher than F, right? That's the tension in the lower side belt will be more than that of the upper side belt. The lower side belt, because of more tension, is known as tight side, right? So this is known as tight side, whereas the upper side belt, because it is known as slack side, right? So top side is slack side with less tension, bottom side is tight side with high tension, right? And here is the top view of the drive, right? So this is a shaft, right? What you're seeing here, this is a shaft, this is a pulley, right? This is a pulley, and this is a belt, right? This is a belt which is running this way, right? So this pulley is also rotating this way, this pulley is also rotating this way. Both of them are rotating in same direction, right? So that's the scenario of the open belt drive. Shafts are arranged parallel to each other and rotating in the same direction. Then we have tight and slack side, right? So we'll elaborate on tight and slack side, right? Belts in motion on pulleys develop tight side tension T1, slack side tension T2, right? So here, tight side, so I can put it as T1, and the slack side tension is T2, right? Tight side tension is created on that section of belt approaching the driver, right? So if you want to find which is tight side and which is low side, right? The tight side on the section of belt approaching the driver, right? So this is the driver, and this is the belt part approaching the driver, and this is the belt part leaving from the driver, right? This is a part approaching the driver, right? A kind of driver pulley is pulling it, right? Which is pulling it, and this side is leaving the driver, or driver is pushing it, right? So the tight side tension is created on the section of belt approaching the driver pulley, right? Approaching the driver pulley. Similarly, slack side tension is created, right, on the section of belt approaching the driven pulley, right? So tight side approaching the driver pulley, slack side either leaving from the driver pulley or approaching the driven pulley, right? So this is how we'll remind how the tight side and slack side is designed, right? So normally tight side would be on the bottom and the slack side would be on the top, right? And again, if you want to go deeply into that, tight side would be the part which is approaching the driver, and the slack side is the part which is either leaving from the driver, we can say, or which is the part which is approaching the driven, right? Right. Then we have the cross belt drive, right? Either we can say it as cross belt or twist belt. The cross or twist belt drive is used with shafts arranged parallel and rotating in the opposite directions, right? So as like this open belt, this is also parallel, right? You see the axis, this is parallel, but here the rotation of the pulleys are opposite side, right? So here the driver, it is rotating on the clockwise direction, right? Driver is rotating on the clockwise direction, while the driven, which is rotating on the anti-clockwise direction, right? That is rotating in the anti-clockwise direction, right? So this is the difference between crossing and open link. Both of the pulleys are or shafts are in parallel, but in the open drive, this driver and the driven are rotating in the same direction. But in this cross belt, driver is rotating in one direction and the driven is rotating in the opposite direction of the driver, right? So the shafts are in parallel and rotating in opposite direction. In the case, the driver pulls the belt from one side RQ, right? So the driver, this is the driver, pulls the belt from one side, so this side from RQ side, that is tight side, and delivers it to the other side, right? So if it pulls in this direction, it will deliver it in this direction, right? Because this is the driver, right? And delivers it to the other side, that is LM, right? LM. So here tight side is RQ, right? Tight side is RQ and slack side is LM. Thus the tension in the belt RQ will be more than that in the belt RM, right? So RQ, the tension is more than the tension in the LM, right? LM. The belt RQ, because of more tension, is known as tight side, whereas the belt LM is known as the slack side, right? So here RQ is the tight side and LM is the slack side. We can say it in the other way also, right? So tight side mean, I told you, the belt which is approaching the driver, right? So the belt which is approaching the driver is RQ, right? Belt which is approaching the driver is RQ, and therefore this is the tight side, right? And slack side, I told you, the portion which is leaving from the driver or approaching the driven, right? So here is the driven, so the region approaching the driven, so you see this aroma, the belt is running this way and running this way, right? So the portion which is approaching the driven is LM, right? LM. So that's why LM is the slack side, right? LM is the slack side. All right. So this is the front view, and if you draw it in top view, you can see like this. So here is the shaft, right? And here is the pulley, all right? And this is the belt, right? This is the belt. This is called as the cross link or twist belt drive, right? Twist belt drive or cross belt drive, right? So this definition for tight and slack side is applicable for everywhere, right? The belt part which is approaching the driver, which is tight side. The belt part which is approaching the driven, which is called as the slack side, right? So this is all about cross belt drive. Then we have quarter turn belt drive, right? Quarter turn belt drive. You see, quarter means 1/4 of a circle, right? You know that. So if I can draw a circle, quarter means 1/4 of that, right? So this is what called as this quarter. So you see here, this is 1/4 of a circle, right? This is 1/4 of a circle. So this is why it is called as a quarter turn belt drive, right? The quarter turn belt drive also known as right angle belt drive. So here we can call it as a name right angle belt drive also. There you see right angle belt drive is used with shaft arranged at right angles and rotating in one definite direction, right? So for this, the shafts need to be arranged in right angle. So here you see this shaft is arranged this way and rotating like this, right? Rotating like this. But here if you see this shaft, this is going inwards and rotating like this, right? So the shafts are arranged in right angles, right? So here also you see this is the axis of the shaft, which is rotating this way, okay? And this is the axis of the shaft, and which is rotating this way. And if you extend, they are meeting at a right angle, right? They are meeting at right angle. So similar cases applicable for here also, right? This is axis of this is axis of this, and they are meeting at right angle, right? So here the quarter turn belt drive is used when the shafts are arranged at right angles, right? Shafts are arranged at right angles and rotating in the one definite direction, right? So here, so for example, this is the driver, right, which is rotating only in this direction, right? So the power is now transmitted to the driven, which is rotating in exact one definite direction, right? You can't change the direction, all right? In order to prevent the belt from leaving the pulley, right? So maybe there's a possibility this pulley may move that side or this side and move out from the pulley, right? So in order to prevent this, the width of the faces of the pulley should be greater than that of 1.4 B, where B is the width of the belt, right? So if I consider this as a width of the belt, okay? So we'll keep this as a length, and this is the width of the blade, where B is the width of the blade. So I put it as B, right? Then the pulley, right? The width of the pulley should be greater than 1.4 times greater than that of B, right? So this is, I put W, this is a pulley. So this all I'm drawing in top view, okay? This is pulley and this is belt, okay? So here 1.4 B, right? 1.4 B would be equal to W. W is the width of the pulley, or W should be greater than 1.4 of the B, right? Should be greater than, right? This is greater than 1.4 of the 4 times of the B, right? So this condition is defined because there is possibility this pulley may move this way or this way and jump out of the, sorry, not pulley, the belt may move this way or this way and jump out of the pulley. In order to prevent this, the width of the face of the pulley, right? So this is the face of the pulley, the width of the face of the pulley, that is, I will call it as W, should be greater or equal to, right? It should be greater or equal to 1.4 B, right? 1.4 B, where the B is the width of the belt, right? So here, this is the width of the belt, and this is the width of the pulley, right? So this width of the pulley should either be equal to 1.4 B or should be greater than 1.4 B, right? In case the pulleys cannot be arranged, or when the reversible motion is desired, then a quarter turn belt drive with guide pulley may be used, right? So here this is quarter turn belt, right? So in case pulleys cannot be arranged, right? So if you see, there can be possibility there is a small kind of, lack of tension over this in region, right? So in case if it is a problem, or when the reversible motion is desired, right? So that's what mentioned here, definite direction. So reversible motion is not possible here. But if you want the definite reversible motion also, right? If you want the reversible motion also, then we will go for the guide pulley, right? This is called as the guide pulley. So if you put this guide pulley over here, what will happen? Either this could be driver moving this way and this could be driven moving this way, or this could be driver moving this way and This could be driven moving this way. Why? Because it is passing over a guide pulley, right? So the chance of moving out of the track is less when compared to a system without a guide pulley, right? So here you can see, say for example, if this is rotating this way and this is rotating this way, better to have on that particular direction. We can't change it to let this move on this direction and let it move on this direction. That's difficult, right? So that's what it mentioned as one definite direction, right? But in case if we want to change the reverse direction also, then we'll go for a guide pulley, right? So this guide pulley in turn increase the tension also, right? That's beneficial, right? So for quarter ton belt drive, the width of the pulley should be greater than or equal to 1.4 times the width of the belt, right? Width of the pulley is 1.4 times greater than the width of the belt. Then we have belt drive with idler pulleys, right? Belt drive with idler pulleys. So here you see in the first diagram, there's a driver pulley, there's a driven pulley, and there's an idler pulley. Okay, there are 3 pulleys. In the previous case, if you see, there are only 2 pulleys. One is driver and the other one is the driven. Here we have another pulley which is called as the idler pulley. We'll see what are they doing here. These idler pulleys, what are they doing here? A belt drive with an idler pulley is used with shafts arranged parallel, and when an open belt drive cannot be used due to small angle of contact on the smaller pulley, right? So if I can draw, anyhow they are going to be parallel, right? We know this is going to be parallel since this is an open drive, right? That's okay. Then cannot be used due to small angle of contact on the smaller pulley. So if there is no idler pulley over here, right? If there is no idler pulley over here, the belt drive would move something like this, right? And this also can move something like this. So okay. So due to the addition of this idler pulley, okay, the angle of contact, right, it's little bit increased, right? So angle of contact on driver, it's not that important, but on the driven, it's important, right? So if there is no idler pulley, then it might have gone this way, right? This would be the angle of contact, right? This would be the angle of contact, which I'm going to shade it in like green color, right? So if there is no idler pulley, I'm talking about no idler pulley, yeah. This is going to be the angle of contact. But with the help of idler pulley, right? With the help of idler pulley, which is increased to this region, right? So that I will color it in yellow color, right? So this region is the increase in the angle of contact, right? This region is the increase in the angle of contact. So if the distance is small, I told you that's not desirable, right? If the distance is too small, that's not desirable. So under such situation, only this much distance is provided, means we need to go for some other means to increase the efficiency and to high transmission of power, right? So there we will include a kind of idler pulley in order to increase the angle of contact. I told you if the angle of contact is increased, then the power transmission will also be increased, right? So if an open belt drive used due to small angle of contact on the smaller pulley, right? If there is small angle of contact, we can go for the idler pulley. This type of drive is provided to obtain high velocity ratio, right? High velocity ratio, and when the required belt tension cannot be obtained by other means, right? There's one more thing. So if this belt maybe with time has increased in length, right? So that may slide over the pulley, right? Because pulley and the shaft, we can't change the distance, right? We can't change the distance like several times. Maybe with time, the belt could be lengthened in size, and when you use the belt here, that may not be able to produce a same tension like this. Say for example, that is going like this. Okay, this region is extended region that may not be in contact with the this pulley, right? Say for example, so this region This region which I am putting is extended due to the usage of it. So in this case, we can't increase the length of the shaft, right? We can't break it and build it again. That we can't do. So in this case, what can we do is, this is also another reason to increase the idler here. So if you use the idler here, what will happen? This belt may go like this way and it will come to this way. So this increase in length, right? This increase in length may be accompanied by this extra length, right? You see here, this extra length, we can accompany this extension, right? So this is also another reason why we use this IWS. This type of drive is provided to obtain high velocity ratio, and when the required belt tension cannot be obtained by other means, right? So if it is going like this, the tension cannot be obtained, right? Either you need to change the belt or you need to move the shafts apart. Other than these two, this is easy, right? Because this is name by name, it is IW. This is not going to do any work, and this is not going to go do any impact on the transmission of power, right? This is IW. This does not work anywhere. When it is desired to transmit motion from one shaft to several shafts, all arranged in parallel, a belt drive with many IWs may be employed. So this statement is about this diagram. I'll come for that. So we'll finish with this first, right? So there are two reasons specifically why we use for IWA, why we go for IWA. One is to improve the angle of contact if the two shafts are present near, right? If the distance between the shaft is less. This is first reason. And the second reason is to increase the velocity ratio by increasing the tension, right? By increasing the tension and transmit the power from driver to driven efficiently, right? So this is the other reason. So if the space between the shafts are constant, or if it is confined, it cannot be changed. In that case, we will go for IW in order to make the small changes in the length of the belt, right? We can't cut the belt somewhere here and tie it again. That's not good, right? That may make like loose points. So here we will tie it by applying a IW, right? So these are the two reasons why we go for IWs. When it is desired to transmit motion from one shaft to several shafts. So here is your driver shaft. This is one shaft, right, which is rotating in anti-clockwise. One shaft to several shafts, right? Several shafts, all arranged in parallel. You see here, these all are arranged in parallel. Okay, all are arranged in parallel to each other. Under such situation, a belt drive with many IWs may be employed. Right? A belt drive, right? This is a belt drive. You see, one belt drive is driven all the pulleys, right? With several idler pulleys, right, may be employed. So if I have like one driver pulley here, so I can make another arrangement also, right? So distance is unchanged. So one driven pulley, another driven pulley, and another driven pulley, right? So same diagram I'm drawing back. So this is our driver, and these three are our driven pulleys, right? So if I don't have any idler pulleys here, how this belt is going to travel is, this will go like this, right? This may go like this and go like this. So this is how this belt is going to travel, right? So in this case, if you see, the angle of contact here in this pulley is from there to there, right? From this pulley is there to there. For this pulley, it is from here to here, right? So this is all the angle of contact is. But if I insert two driver pulleys here, not driver pulleys, sorry, idler pulleys here, you see the angle of contact is from here to here, right? This region is the angle of contact. Okay, and for this pulley, this is from here to here, right? This is the angle of contact, right? For this pulley, again, it is from here to here. This is the angle of contact, right? So here, if you compare these two diagrams, right, the angle of contact of these pulleys and angle of contact of these pulleys, if you compare, the angle of contact is very much higher in this type of pulley than this pulley. right? This set of pulleys, the angle of contact is very much higher, right? So this is a reason when we are using a one driver and several driven, right? So one driver pulley to drive different pulleys or different driven pulleys, we'll go for numerous number of idler pulleys, right? Number of idler pulleys, right? So this in turn increase the angle of contact, right? Which will again increase the power transmission, right? So angle of contact is increasing, which means the power transmission is also increasing. And also, in case if there is any problem with the tension, right? If the wire is lengthened and tension is not good, I mean not enough, then also we can use this idler pulleys to maintain that, right? So whatever reasons I told here is applicable for here also, since we have idler pulleys. And the specific and special reason for this is to improve the efficiency, right? So this is the idler pulley and their job, right? So this does not have any effect on the power transmission, but this may enhance the efficiency of the pulley, right? System of pulleys. All right. Okay. Then we have compound belt drive, right? Compound belt drive. So this is the top view, right? And here is the front view. Compound belt drive means is used when power is transmitted from one shaft to another through a number of pulleys, right? Through a number of pulleys. So here you see, say for example, yeah, this is the driver, right? This is the driver. So now the power generation is at this point, right? Power generation is at the driver. This power need to be transmitted to this point, right? This driven, right? So power transmitted, power generated from here need to be transmitted there. I mean this point, right? So here we have a driver, okay, and this number 2, right? This is the driven for this driver, right? Or drive follower for this driver. This is driver. This is follower of this driver. All right. But this number 2 follower and the number 3 driver, they are in the same shaft, right? They are in the same shaft. Due to the action of this follower, this shaft may rotate, right? Since the driver is rotating, follower is rotating, the shaft may rotate. When this shaft is rotating, this driver is again going to rotate, right? So now the power from here transmitted to here, right? Now the power is here. After the transmission, it has transmitted to the follower. From the follower, it has transmitted to the shaft. From the shaft, it has transmitted to the third number pulley, which is the driver, again for this follower, right? So here, now the power is in. When you connect this driver with this follower, right, what will happen? This power which is over here now would be transmitted to this position, right? So here, this is driver and this is follower, okay? So this is what called as the compound belt drive, right? So here you see there are more than one pulley at a shaft, right? More than one pulley at a shaft. This is what called as the compound belt drive, right? Power generated here, transmitted by belts to the follower here, right? That follower transmitted it to the shaft. Again, from this shaft, this driver get the motion. Now this motion or power is transmitted to this follower, right? So power generated here has been now transmitted to here, right? If we don't have this compound belt drive here, right? Compound pulley here, what will happen? The power which is generated here need to be directly transmitted to this position, right? So we know if it is like large distance apart, that's not desirable, right? Large distance apart, it's not desirable. It may have weight over here, right? It may impact the angle of contact. There are several problems, right? So this compound belt drive is helpful in solving such kind of issues, right? Solving such kind of issues. So now the power transmitter here has been successfully transmitted to this location by a compound belt drive, right? This is called as the compound belt drive. RPM is going to be generated here, right? Say for example, we have A RPM here, okay, and which is transmitted to here, maybe some B, okay, and this one and this one, the RPM is going to be same, right? Because they are rotating in the same shaft, right? Rotations per minute. So if it is rotating in same shaft, the shaft RPM, the follower RPM, the disc driver RPM, they all are going to be same, right? And from here, when it is transformed here, then there would be another RPM, it will be C, right? That is going to be C. Then we have stepped or cone pulley drive. So now we are seeing like different types of drives, huh? Open belt drive, closed belt drive, V belt drive, compound. Now stepped or cone pulley drive. A stepped or cone pulley drive is used for changing the speed of the driven shaft while the main or driving shaft runs at a constant speed, right? So here main or driving shaft, okay, and this is our driven shaft. So if this main driving shaft is run at constant speed, right? So I'll put that speed as V, okay. But now I have to change the velocity of the driven shaft, okay. So what can I do is I may move this belt from one shaft to the other, not shaft, sorry, one pulley to the other, right? So here you see the diameter of this pulley is smaller than the diameter of this pulley, and that is smaller than this pulley, right? So when the diameter increases, the velocity decreases, right? So based on this, I can move this belt from one pulley to the other, right? While the main or driving shaft runs at a constant speed. So when this is run at a constant speed, we don't need to stop this, but we can adjust only with these pulleys, right? This is accompanied by shifting the belt from one part of the step to the other, right? So this is looking like a kind of step, right? That's why this is called as the step torque pulley. So we can move this belt from one pulley to the other, right? So that may produce the velocity if necessary, right? So we don't have to do anything with the driving shaft. So it's enough only if we do with the driven shaft, right? Then fast and loose pulley drive, right? Fast and loose. Fast and loose pulley drive is used when the driven or machine shaft is to be started or stopped whenever desired without interfering with the driving shaft, right? So again, this is our driving pulley, right? This is rotating, okay? Now we need to stop the motion, I mean stop the work or whatever it is. There's some failure occurred and we need to stop the motion. So we don't have to go and do anything with the driving pulley, since that may be driving another two pulleys this side also, right? Since there's a main driving pulley that may run few other pulleys this side also. That's possible, right? So if I stop the driving pulley, what will happen? The complete movement would be stopped, right? So this side also would be stopped, but I don't need that, right? I have some production line this way and some problem with the production line here, which does not have anything to do with the production line here. So I can let this region work and I need to stop this region, right? So if I want to stop this region, I don't have to go and do with the driving pulley. What I can do is I can stop only here with the driven pulley, right? So here this is a shaft, right? This is a shaft, machine shaft, and here is a fast pulley or driven pulley. So when this belt is here, that was working, right? This was rotating and that was working. I need to stop the machine, which means I can move this belt from here to here. There is a loose pulley which is not going to transmit any power. So now the motion is come to a full stoppage, right? So here we'll see fast and loose pulley drive is used when the driven or machine shaft is to be started or stopped whenever desired without interfering with the driving shaft. So let the driving shaft run, right? Don't do anything with this. How we are going to control over here alone? The pulley which is keyed to the machine shaft is called fast pulley, right? So a pulley which is keyed to the machine shaft. So this is the fast pulley, which may be attached to some machine, okay, which may be attached to some machine which is running or working, right? Now the production is over and I need to stop this machine. All right. A loose pulley runs freely over the machine shaft and is incapable of transmitting any power, right? Incapable of transmitting any power. So there we will have a loose pulley also, which may not attach to the main shaft, or may not main shaft machine, right? So if I move this belt from here to here, this is not attached with the machine, right? This will just run as it is, but the work will not happen. Why? Only the fast pulley is attached with the machine, right? Fast pulley is attached with the machine. Loose pulley is not attached with the machine, right? So if I want to stop the work without doing anything with the driving pulley, what will I do? I move this belt from here to here, right? So now this may rotate, but work will not be done. If we need it again, maybe after some time, after maybe like lunch break or something, if they are coming for work again, then they will move it from here to here back, right? So that will move from here to here, then again the work would be started, right? So a loose pulley runs freely over the machine shaft and is incapable of transmitting any power, right? This is not going to transmit any power since it is not connected with the machine. When the driven shaft is required to be stopped, right? When the driven shaft is required to be stopped, the belt is pushed onto the loose pulley by means of sliding bar having belt forks, right? So this would be moved to this pulley and the work on this machine would be stopped, right? So this is why I call it a fast and loose pulley drive, right? So fast pulley drive is attached to the machine. Loose pulley drive is not attached to the machine but attached to the shaft, right? And driving pulley is always going to be run. We don't have to do anything with the driving pulley. So what will I do if I want to stop my machine? I will deal with the driven pulley only. So what I do with the follower pulley, I will I will move the belt from the follower pulley, which is attached with the machine, to the loose pulley, which is not attached with the machine. So power is not going to be transmitted, but the machine is, pulley is going to be run. Since it is not connected with the machine, there won't be any work, right? So this is what called as the fast and loose pulley drive. Okay.